Alrighty, as I'm waiting for everyone else to get here, people to log in and answer the call for the class, we're gonna get started. We've got a good chunk of stuff that we're gonna try and get through today. The first thing that we're going to talk about, just to make sure that it is covered, is some things about preparing for the AP exams, whether it be this one or multiple exams. It depends on your classes. There's a little presentation that Ms. Booth put together along with a survey that the district has that you need to fill out if you're taking any AP exams, whether it be for my course or another course. Right? This is not course specific, it's for AP in general. All right, so we're going to go through this presentation and make sure you guys get the link to the survey, so you can do that because it needs to be done if you have not done it yet. So we'll start with this, and then we'll get into our lesson for today. Alrighty, so here we are. All right, so AP testing survey. All right, this needs to be done before the end of the day on the 12th, and the end of the day is like the end of the school day. So it says 3 o'clock. The information will come out again shortly. All right, and so we're going to go through this. Should only take a few minutes. All right, first, if you're taking one of the world languages exams, all right, you are required to take them in person at school. There is not a remote option for these exams. That is AP Spanish Language and Culture, AP Spanish Literature and Culture, and AP French Language and Culture. Right, due to the nature of these exams, you must take them in person. Right, so please keep that in mind if you're registered for any of those exams. Right, and the dates for those are here. May 21st. Right. These are the digital exam dates. The digital exams, it is possible to take these at home digitally or at school digitally. Right. I'll point out the statistics exam, is on Thursday, June 10th at the 1 p.m. our time testing slot. Okay. And please take note of this to see when any other exams you might be taking could be. If you're taking an AP exam, you need to complete this important survey. It takes about 5 minutes. I'm going to put the link for that in the chat. Boom. All right, so the link for this survey is in the chat of Teams. So you should click on that. If you have not already done this survey, you may have gotten this in another AP class. That's fine if you've done it already. You don't need to do it again. If you need to speak with your family about some of the questions, please fill it out during the next class or next earliest convenience, but no later than Monday, April 12th at 3 p.m. All right, this survey is required for all students because we need to know if you're unable to test at home, and we need to know your technology needs. Phones and tablets will not work for the exam this year. I believe last year, because of the kind of like emergency situation we were in, as far as like we just weren't prepared to do stuff digitally, you were able to use phones and or tablets when taking the AP exams. That is not the case this year. You must take them on a laptop or desktop. And again, if you're taking the AP Spanish Ling or AP Spanish Lit, French Ling, AP Italian, you will be testing at school in person. They're not available for at-home digital format. In the survey, you need to provide all your student information and your high school and grade level. You will then need to select all the AP exams that you're registered to take in My AP, not just if you're taking more than one AP exam, select all of them, right? This does not matter if it's in person or digital. Select any and all exams you are taking. All right, you're going to be taking your digital exams at home. Do you have a laptop or desktop to take the exam? If you do not have a laptop or desktop, your school will follow up with information on scheduling a device pickup. Note, for AP Testing 2021, phones and tablets will not work. So this part, answer, yes, I have a laptop or desktop. No, I need to be issued one. And then the next screen, please confirm that you are able to take these digital exams at home. Yes, I can. You will be done with the survey. I will like to ask permission to take the digital exams at school. Be given one more question. If you want permission to take the exams at school, you must select the reason why you cannot take them at home. Select all the reasons that apply. Your AP testing coordinator will be in contact with you about your request for taking the digital exams in person at school. Right, so this survey needs to be filled out. That's all the survey. It's not a very long survey. It doesn't require a ton of typing, but it needs to be filled out so that the district and the school, right, we have all the information we need to make sure that everyone is accommodated for taking their AP exams. Right. Is there any questions about this initial step on AP exam setup? And then in that case, we're going to move on to the activity for today, which will be, again, kind of a hybrid between a presentation and some practice problems using Desmos. So we're going to get this going. I will drop the link for the Desmos activity into the chat here momentarily. All right, so we're going to get on moving here. We're going to open it up to the next slide, which is our introduction for section 9.3, tests about a population mean. All right, confidence intervals and significance tests for a population proportion P are based on Z values from the standard normal distribution. That's what we saw in the previous section, 9.2. Right, those ones behaved very similarly to like standardize a score, find the Z-score, get the proportion under the curve. Right, we're just using slightly different variations of those formulas. Inference about a population mean mu uses a t distribution with n-1 degrees of freedom, meaning we'll be using table B again, just like we did in the last chapter. Except in this case, except in the rare case when the population standard deviation sigma is known. Right, in that case, we can probably just use a normal distribution. We learned how to construct confidence intervals for a population mean in section 8.3. Now we'll examine the details of testing a claim about an unknown parameter, mu. Right, so that is the goal today. Next, checking conditions. Right, just like in section 8.3, when dealing with confidence intervals for means, we have the same 3 conditions to check when dealing with a significance test for a mean. Right. Number 1, we got to check that it is random. The data came from a well-designed random sample or randomized experiment. The 10% condition must be met when sampling without replacement. Right. And then we have the normal large sample. The population has a normal distribution or the sample size is large, greater than or equal to 30. If either of those 2 things happen, then we're good to go. If the population distribution has unknown shape, meaning we don't know if it's normal, and the sample size is less than 30, then we need to use a graph of the sample data to assess the normality of the population. We have to make a histogram, at least, or a dot plot, or something that will let us see the shape of the distribution. Do not use T procedures if the graph shows strong skewness or outliers. We'll see an example of that today. Is there any questions or anything I can clarify about the conditions that we must check, either when constructing a confidence interval or performing a significance test about a mean? All right. So then once we've checked our conditions, that leads us into doing some calculations. All right, the type of calculations and the inference method we will use today will be the one sample t-test for a mean. All right, so when conditions are met, we can test a claim about a population mean mu using the one sample t-test. All right, we choose an SRS of size n from a large population that contains an unknown mean mu. To test the hypotheses H naught such that mu equals mu naught. Compute the one sample t statistic, t equals x bar, the sample mean, minus mu naught, the null hypothesis mean, divided by s sub x, the sample standard deviation, divided by the square root of n, the sample size. Right, and that allows us to calculate the t statistic. We will then use the t statistic to find the p-value by calculating the probability of getting a t statistic this large or larger in the direction specified by the alternative hypothesis in a t distribution with degrees of freedom n equals 1, n minus 1. Sorry guys, again, a little tired today. And we see this set of graphs similar to what we saw with section 9.2 with our proportions, right? If the alternative is that mu is greater than the null hypothesis, we do the area to the right of t. If we're looking at less than, then to the left of t. If we're simply not equal to, we do both. It is a two-sided, and we just find one area, either to the right of positive t or to the left of negative t, and then multiply it by 2. Right, and that gives us what we need. Right. So this is the main formula, so to say, that we will use. The one sample t test formula here. Some quick table B reminders. Right? We need to use table B wisely. Table B gives a range of possible p-values for a significance. We can still draw a conclusion from the test in much the same way as if we had a single probability by comparing the range of possible p-values to our desired significance level. So essentially what this is saying is that when we find where the t statistic is in table B, it will be between a couple of values on table B. Right, the p-value will lie between two values. We won't be able to find an exact or very accurate p-value. We'll get a range. Right? But that's okay. We can still use the range to then relate it back to the significance level, the alpha, right? And say whether it's less than that or greater than that based on the range of possible answers or possible p-values. Right, table B includes probabilities only for t distributions with degrees of freedom from 1 to 30, and then skips to degrees of freedom equaling 40, 50, 60, 80, 100, and 1000. The bottom row gives probabilities for degrees of freedom equaling infinity, which corresponds to the standard normal curve. Note, if the degree of freedom you need is not provided in table B, use the next lower degree of freedom that is available. In other words, I refer to this as the Price is Right rule. You want to get as close to your degrees of freedom as possible, but you are not allowed to go over. Right? Not even by 1. So suppose you have degrees of freedom of 79. You would not use 80, you would go back down to 60. Right? That is the closest value that is lower than the degrees of freedom that we have. Table B shows probabilities only for positive values of t. To find a p-value for a negative value of t, we use the symmetry of the t distributions. In other words, if your t value is negative 1.9, you will simply find 1.9 within table B and use the corresponding p-values for 1.9 because it's going to be the same as negative 1.9. We have symmetry. Okay, is there any questions? Or anything I can clarify about table B? Next, we're going to look at an example of how to check conditions, use the one sample t-test in table B to then make a conclusion about a significance level. Right. This is not an example that you guys will work through. I'm going to show you guys how to do this one. So longer lasting batteries. Right. A company claimed to have developed a new AAA battery that lasts longer than its regular AAA batteries. Based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. An SRS of 15 new batteries lasted an average of 33.9 hours with a standard deviation of 9.8 hours. Do these data give convincing evidence that the new batteries last longer on average? All right, so this is our context. This is where we're starting, right? And we're going to use just what's here to get to a conclusion. All right, so we're going to switch over to OneNote because that's where I have the work for this. And here we are. So a company claimed, here's our context again, right? The first thing I did was just circle, highlight the things that I need, the numbers from this context, and I labeled them with what they relate to within things that I need to use. Right? The regular AAA batteries last for 30 hours. That becomes the null hypothesis. Right? That would be if there's no difference between the regular batteries and the new batteries, then the new batteries will have the same average battery life. The sample mean is 33.9 hours and the sample standard deviation is 9.8. So I have those labeled as x bar and s sub x. Right. I then put all this stuff into the format I need. Right. The null hypothesis is that mu equals 30 hours versus the alternative is mu is greater than 30 hours. X bar equals 33.9. Standard deviation of the sample is 9.8. Sample size is 15. This is my one sample t-test t statistic formula. So I just have that there so I can use it later. Now, the first part of this is our statement, what we're going to do. All right, we want to test the hypotheses. Null hypothesis such that mu equals 30 versus the alternative that mu is greater than 30, where mu represents the true average battery life of the new batteries. Since no alpha was given, we will use alpha equaling 0.05 for the significance level. This is fairly common. If you're not provided the significance level in the context, use 0.05. Right? The common significance levels to use would be 0.01, 0.05, or 0.1. We'll just use the one in the middle, right? It's pretty common to do that, unless you were told what to use. Then obviously use what they give you. Right? Next, we plan. If conditions are met, we will use a one sample t-test on mu. So again, hopefully you guys are on the shared screen in Teams. That's where you can see this work that I'm walking through. Again, so we're checking conditions. Random, the sample was an SRS. We're good. 10%. It's safe to assume that 15 batteries is less than 10% of all the new batteries. Right? We don't know that for sure, but based on the context, it's pretty safe to assume that they didn't just make 150 of these batteries. And normal large sample. Unfortunately, the sample size of 15 is less than 30. We don't know what the parent population shape is, the shape of the distribution is. However, based on the context we were given, the distribution of the sample is described as normal, right? We're given a mean and standard deviation. It's kind of the best thing we have to go off of. We don't have the individual statistics. We don't have the individual battery lives to make a histogram or make a dot plot. So this is the best we can do. And for the purposes of the exercise, we're going to continue based on this being normal or approximately normal. Is there any questions so far? Anything clarify? Okay. Then we do some math. We need to find the t-statistic first and then find the p-value. So our t-statistic, t equals x bar minus mu naught divided by standard deviation of the sample divided by the square root of n. So we get that is equal to 33.9 minus 30 divided by 9.8 divided by the square root of 15. And we get approximately 1.54, right? And we have, before we can go on to table B, we need the degrees of freedom. We have 14 for degrees of freedom. So we get table B here, right? 14 is actually on table B, so we use it. And we go across here until we get to these two values, because between 1.345 and 1.761 is 1.54. So that means our t statistic lies between these two numbers in 14 degrees of freedom, which means that our p-value lies between 0.05 and 0.1. And that's what we get up here. P-value is between 0.05 and 0.1. I know it might be a little confusing. We always want to list the numbers when we write them out as the smaller one first, bigger one second, even though they're listed as the larger number first and the smaller one second on the table here. All right. So that's our p-value. And this will be enough. We'll be able to make our conclusion just with knowing that the p-value is between, it's greater than 0.05 and less than 0.1. Right. So we get to our conclusion statement. Since the p-value is greater than alpha equaling 0.05, we fail to reject the null hypothesis. Right? We know that it's greater than 0.05. That's in the range here. It's greater than 0.05, less than 0.1. We do not have convincing evidence that the average battery life of the new AAA batteries is greater than the regular batteries or the old batteries. And that is our four-step process. Are there any questions? Is there anything I can clarify? All right. So then moving on. The next screen here, you don't need to do that right now. That is a video of me going through the example. Obviously, I just did that. This is just here, so if you want to go back into this activity, you can watch the video and get what you just got from me talking about it. So that leads us to our first question. Right, ancient air, we need to check conditions. So everyone should be onto the 8th screen of this set of slides here. Right. So the composition of the Earth's atmosphere may have changed over time. To try to discover the nature of the atmosphere long ago, we can examine the gas in bubbles inside ancient amber. Amber is tree resin that has hardened and been trapped in rocks. The gas in the bubbles within amber should be a sample of the atmosphere at the time the amber was formed. Measurements on 9 specimens of amber from the late Cretaceous era, 75 to 95 million years ago, give these percents of nitrogen. We have our 9 data points here. Explain why we should not carry out a one sample t-test in this setting. So please use the little text entry window here to explain why we cannot carry out a one sample t-test. What conditions have not been met? We'll talk about this in a few minutes. All right, awesome. A lot of you guys have some very good ideas. I saw a bunch of people writing in their responses. So yeah, essentially, as many of you guys had, many of you guys got at least one of the reasons. The sample size is too small. It is less than 30. We do not know if the sample was chosen at random, right? We just know that we have 9 specimens. We don't know where they came from or how they got them or how they were chosen. Right? And we don't know if the parent population is normal. And when we graph these, right, as a histogram or a dot plot, we will see that the distribution is left skewed, strongly left skewed, which again violates our normal large sample requirement. Right? So basically, we can't confirm any of the requirements, to be honest, but we can for sure say that the sample is small, right? That we don't know if it's random, and we're pretty sure it's not normal. All right. So those are the reasons. Is there any questions? Anything I can clarify for this example? All right. So we'll open up the next question on screen 9. All right, finding a p-value. So we have our context here. Hemoglobin is a protein in red blood cells that carries oxygen from the lungs to body tissue. People with fewer than 12 milligrams of hemoglobin per deciliter of blood are anemic. A public health official in Jordan suspects that Jordanian children are at risk of anemia. He measures a random sample of 50 children. We are going to assume all necessary conditions have been met. The sample mean hemoglobin level was 11.3 milligrams per deciliter, and the sample standard deviation was 1.6 milligrams per deciliter. You need to calculate the test statistic T, and then find the p-value using table B. Again, you will find a range for the p-value. You will not find one p-value. There's a way to do it. We'll look at that after we see this example. We can use our calculator. All right, so take some time here on this one, and then we shall talk about it. If you have any questions while you're working, please put them in the chat. Let me know. Oh, also, you have multiple ways of answering the question here. You can actually write in this space if you want, if you have that ability. With the device that you're using, you can type in this space. You can type math in this space, or you can simply use the text entry box below, or you can upload an image of your work that you've done by hand. You have many ways to submit work on this question. So we'll get started, and then we'll talk about it. I can see that some of you guys are still working on this, which is awesome. So as you're working, we're going to talk about this. Please feel free to continue working. On my shared screen here, I'm going to show the work. So here we go. again, we have, let's use, not getting on my screen, okay. There. All right, so the null hypothesis, right? Mu is equal to 12 milligrams per deciliter. Alternative, mu is less than 12. Sample mean 11.3, sample standard deviation 1.6, n equals 50. It's our sample size. All right, so these things all get populated into the t statistic formula. 11.3 minus 12 divided by 1.6 divided by square root of 50. If you're putting this into your calculator, right, I would suggest parentheses, right, divided by this in parentheses. Right, so if you're using your TI-84, right, you need to be careful in how you're punching these things in. Right, do 11.3 minus 12 divided by, parentheses again, 1.6 divided by square root of 50. Right, so that way it performs the operations correctly. Right, it would be really easy to have all the correct numbers and have it look correct on your paper and not punch it in correctly and get a completely weird answer. Right, so please be careful of that. All right, so we do get negative 3.094 as the t statistic. We then go to table B with degrees of freedom 50 minus 1 equals 49. Right, and finding 3.094 on table B, where we have 40 for the degrees of freedom we're using on table B, we see that the p-value lies between 0.001 and 0.0025. Now we can also get a more exact answer by using the calculator and using the t-test function, which is under stat. This middle button here, we can go to stat, click to the right to tests, and select the second option, the t-test. As you can see, I've already got the stuff set up in here for our t-test. We're using the t-test using the actual summary statistics that we were provided, right? So we have 12 for the null hypothesis, the sample mean, sample standard deviation, sample size, and that our alternative is that we are less than the null hypothesis. We'll just click all down and tell it to calculate. And there we have basically the same results, right? Except this one gives us the p-value, right? P equals 0.0016312224, which, right, we have it rounded here, but also notice it is in between 0.001 and 0.0025, right? Which it should be based on what we did. All right, so we can also use our calculator to get a more exact answer. All right. Is there any questions? Anything I can clarify? Next, we have a one-sided test. Right, suppose you carry out a significance test on the null hypothesis mu equals 5 versus the alternative that mu is less than 5 based on a sample size of n equals 20 and obtain t equals a negative 1.81. You can find the p-value for this test using table B or technology. However, the technology is a different function on the calculator we haven't shown yet. I haven't shown. However, we'll show it after this, so I suggest using table B. And then what conclusion would you draw at the 5% significance level and at the 1% significance level? All right, just using table B, you'll have enough information to be able to answer both of these conditions. All right, so let's take a few minutes and work on this bad boy, and then we'll talk about it. All right, guys, let's continue. So with our one-sided test here, well, let's look at what we got. So using table B, we use degrees of freedom of 19, right? And that places it places us at a p-value of 0.05, between 0.05 and 0.025. Right. Let me show you this on the table. There we go. All right. So we have degrees of freedom of 19. All right. Bring that over. And our t is negative 1.81, but remember, we don't get negative values here, so we'll use 1.81. Right, that's going to fall between these two numbers, 1.729 and 2.093, which means our p-value is between 0.025 and 0.05. Right. Using technology, we would use the function of TCDF in our distribution menu. Right. And I will show you that right now. So we find the TCDF function if we go to second and vars. Right above vars, it says distr, distribution. That gives us this menu. That's where we find our normal PDF, normal CDF, inverse normal, blah, blah, blah. We're using TCDF. That is our T distribution. All right. Go enter. Lower bound, big negative number. Upper bound, negative 1.81. We can use the negative value in the calculator. Degrees of freedom, 19. We cannot use the t-test because we do not have the summary statistics for this context. We don't know X bar, we don't know the sample standard deviation. So we cannot use that one. We use this instead. All right, so we'll go ahead and paste this in and hit enter. And there we get our 0.04307, blah, 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 which is in fact between 0.025 and 0.05. All right, so that makes sense. But it gives us a more exact answer that we can then use. However, even if you don't know how to do this, having the range of plausible p-values allows us to answer this question. Right? We definitely know that the p-value is less than 0.05, but greater than 0.025. So for the 5% significance level, because the p-value is less than alpha equals 0.05, we reject the null hypothesis. We have convincing evidence that mu is less than 5. However, at the 1% significance level, right, because we know that the p-value is definitely greater than 0.01, because 0.025 is greater than 0.01, we have because the p-value is greater than 0.01, we fail to reject the null hypothesis. We do not have convincing evidence that mu is less than 5. Right. What can I clarify? What can I help you with? What are your questions? Right, we have this one last question that you guys can follow along with, but I'm not going to ask you to necessarily do right now. I'm just going to show you guys how it would work. It is very similar to the one that we just saw. However, this is a two-sided test, right? So rather than the alternative being that mu is less than or greater than the null hypothesis, we're going to say that it's just not the same, not equal to. So it could be greater than or it could be less than, which gives us that two-tail situation, right? So we can find the p-value using table B or technology. Right? In this case, we'll be using degrees of freedom of 71, which then means on table B we will use 60, and we have a t-statistic of 1.1. So this is essentially the p-values that we'll find using the two different techniques. Right, we have degrees of freedom of 71, which means we again use 60 from table B, right, which we have here. And 1.1 will be between 1.045 and 1.296, which means that the p-value for one tail is between 0.1 and 0.15. That's just for one tail. We have two. So we multiply each of these numbers by 2. 2 times 0.1, 2 times 0.15, and we get that the p-value must be between 0.2 and 0.3. Right. Using technology, we would again use that t-CDF function with the lower bound of 1.1 and an upper bound just of a big number. And degrees of freedom of 71. This will give us, again, the p-value for one tail. So we take this value we'll get here and multiply it by 2, and we get 0.275. And again, this makes sense. It lies between 0.2 and 0.3, which it should, based on what we found on table B, right? And then as far as what conclusion we would make, well, 0.275 is definitely greater than 0.05, and it's definitely greater than 0.01, right? So for both situations, right, because the p-value is greater than alpha, right, we would fail to reject the null hypothesis. We do not have convincing evidence of the alternative. All right. Are there any questions or anything I can clarify here? So there are some more slides here, and they're essentially just notes. There's no more like examples for you guys to do. So I would recommend looking through these. There's another worked example. The only thing we haven't gotten through is our paired data inference. And essentially it's a branch of what we can do with our one sample t-test, except it's where we use two sets of data and we find the difference between the means. And so we get a list of mean differences, right? The average difference between each set of data. And then we run a one sample t-test on that set of differences. And typically you will use a null hypothesis that there is no difference, mu equals 0, and then decide whether or not you're looking for it to be less than 0 or greater than 0, depending on which thing you think has the effect or not. So we'll try to look at an example of that next week, because I'm already over an hour. I've kept you guys for a long time. It was a very long lesson. It was a lot of information, and I feel like we have to stop here. But you are free to look through these things. There's some more notes and an example of how to do a paired data one sample t procedure. which I do recommend watching. It's only 4 minutes. All right. Oh yeah. I'm gonna stop sharing my screen. All right, so that's going to be it for today. If you do have any questions, comments, or concerns about this lesson, previous lessons, assessments that are coming up, previous assessments, anything at all really, please let me know. Feel free to stick around and talk to me about it. Besides that, I will see you guys next week, and I hope you have a wonderful rest of your day.